Hi guys, this is Miss Gariano, and I just wanted to look at an example of solving rational equations with you. So let's look at the problem 2x over x squared minus 1 is equal to 4 over x plus 1 minus 3 over x minus 1. So our first goal is going to be to find the least common denominator, or the LCM of the denominators. But before we can even begin to do that, we need to make sure that each denominator is fully factored. We're good on the x plus 1 and the x minus 1. However, we still need to factor x squared minus 1. So if we're unsure how this will factor, we can always set it equal to 0 and solve. So let's add 1 to both sides. So we get x squared equals 1. Now I'm going to square root both sides, and I get x is equal to, of course, don't forget your plus or minus, the square root of 1 is just 1. So this tells me I get a negative and positive 1 for my factors for x squared minus 1. So we can add that in. So we get 2x over, we want x plus 1 and x minus 1, and that's equal to 4 over x plus 1 minus 3x minus 1. Now our next step is going to be to multiply by our LCM, or the least common denominator. So we want to look at each of the factors here that are represented. So I see I have an x plus 1 here and an x plus 1 here. They're both just a first degree, so I'm going to use an x plus 1 in my LCM. So my LCM is going to be an x plus 1. I also see an x minus 1 showing up here as well as over here. Since they're both just a first degree, there's no need to do any fancy exponent work, so I'm just going to use an x minus 1. So then I'm going to take this LCM, which is x plus 1 times x minus 1, and I'm going to multiply this whole equation by it, meaning I'm going to multiply both sides by x plus 1 and x minus 1 in order to balance the equation. So x plus 1, x minus 1, and we're going to be multiplying fractions, so we can think of this as over 1, and we're going to be the boss and multiply straight across. We're also going to be doing that over here, but I'm going to add some brackets so I remember that I have to distribute this. But I'm going to do x plus 1, x minus 1. And again, we can think of this as a fraction if we put it over 1, since we're going to be multiplying fractions. So then I'm going to get x plus 1, x minus 1 times 2x all over x plus 1, x minus 1, and that will be equal to 4 times x plus 1 and x minus 1. So this is where I took this factor here, the LCM, and distributed it to the first term here on the left side, or sorry, right side of our equation. And we are going to then the 4x plus 1 times 1 just gives us an x plus 1, the denominator. And we're still going to subtract 3 times x plus 1, x minus 1. And again, x minus 1 times 1 is just x minus 1. Alright, now I want to look for common factors that I can cancel out. So, lucky for us, on this side here, x plus 1 will cancel with x plus 1. x minus 1 will cancel with x minus 1. So we're going to only be left with a 2x. Over here, our x plus 1's will cancel. So we'll just be left with a 4 times the quantity x minus 1. And here we have a minus 3. And we're going to cancel out our x minus 1. So it'll just be a minus 3 times x plus 1. So let me rewrite what we have left over after we've done all our canceling. And if we've done it right, if we multiplied by the right amount, the correct LCM, we should be left with no denominators, right? I crossed off all the factors in all the denominators. So I'm going to get 2x is equal to 4 times x minus 1 minus 3 times x plus 1. Then we're just going to work on solving. So I'm going to distribute this 4 through the parentheses, the negative 3 through the parentheses. So I will get 2x equals 4x minus 4 minus 3x minus 3. I'm going to do some combining like terms. So my 4x will combine with the negative 3x, and my minus 4 will combine with my minus 3. So I get 2x is equal to 4x minus 3x is just x, and negative 4 minus 3, oh sorry, yeah, they're both negative. That will give us a negative 7. So I'm going to continue my work over here. I want to solve for x, so I'm going to subtract x from both sides to get the x's on one side of the equation. So we end up with 2x minus an x gives us just 1x equals negative 7. Now that is our solution, but we always want to double check against our restrictions for x. So if I come back up here, my restrictions, I can't let, well, the factored form's better for this part, but the factors are already represented here and here. So I cannot let x be negative 1, and x cannot be positive 1. Neither of those align with our solution down here, which is x equals negative 7. So my next step is to check my answer. So I'm going to plug negative 7 back into my original equation. So I get 2 times negative 7 over negative 7 squared minus 1 is equal to 4 over negative 7 plus 1 minus 3 over negative 7 minus 1. So here we end up with negative 14 over 48 is equal to 4 over negative 6 minus 3 over negative 8. So our double negatives here are going to cancel and give us positives. So when we reduce this down, I'm not going to go through the work because I assume that you guys hate fractions anyway and would plug this in your calculator, but these do, when you add them together, check out. So we get a correct solution of x equals negative 7. So I hope this example was helpful, and as always, you can always ask me questions in class. You could even jot them down if you came across one during this video, and I'd be happy to help answer your question. But if not, I hope you have a wonderful weekend, and I will see you on Monday.